Welcome to Q&A week 5. So we have an exam tomorrow, exam 3, and this will be worth 125 points. You will have 25 multiple choice questions that will cover chapters 19 through 21, and then you'll have 50-point open response. And in your open response, I'm looking for how you draw your structures, your Lewis structures, your formal charges, your intermediates. Can you draw your electron flow arrows from the nucleophile to the electrophile? Can you follow the octet rule? So little things like that. We are going over on this Q&A section, we're going to go over the quiz 5 that you took yesterday. A lot of this was the amines. And the means are actually a hard chapter. So we did have 2 excellent scores on this quiz 5, but we also had a lot of low scores. This is not a time to fast forward through the POGIL exercises. So I think that when you go over those questions in the POGIL, you need to really take your time and think about every question and take some notes on those and really organize your notes and understand what you're doing on those. So I can tell when people got, like if you got less than 5 or 6 on this exam, then I can tell that you probably fast forward through those POGIL exercises or did not look at them at all. And one of the things that I could tell was you need to first classify the amine that you're making. And I said if it's a primary, you really want to use the Gabriel synthesis. And you should know what the Gabriel synthesis is right off the bat. You should know what those reagents are if you watch those videos. And so that's the potassium phthalimide as one of your reagents, and then hydrazine is your second reagent to make the primary amine. If you have a secondary or tertiary amine, then you really need to do reductive amination. And reductive amination is you use a ketone or aldehyde with a little bit of catalytic acid in the amine, and then you reduce it. And a lot of times you use sodium cyanoborohydride, or you can use lithium aluminum hydride. Those are your reagents. Now, if you used ammonia or try to do an SN2 reaction, so if you used ammonia and H3, or you try to do an SN2 reaction with an alkyl halide, you did not get credit. Okay, you're not going to get credit on tomorrow's exam because these are not good ways to synthesize amines. They give low yields and you get complicated over alkylation. And that's what you were supposed to learn from that POGIL. And so if you gave me ammonia or an SN2 reaction with alkyl halide, I really don't think that you took the time to really go through those POGIL exercises. And so I'm kind of bringing this home to you because I want you to do well tomorrow. Okay, so we're going to go over quiz 5. And the other thing I want to point out is I did place some resources. So I opened up another learning module in the very end, and it's just some resources. It's an exam wrapper. So, and also I opened up a practice exam on sapling, and I also placed a video that was a review video. I want you to do well on your final exam. Your final exam is going to be 50 questions, and it's going to cover organic 1 and 2, and it'll be multiple choice. You will not get the answers to these. Now, I will give you a 5-point bonus if you answer So if you do the exam wrapper, but you also have to answer the questions that I put in your announcement. So there's about 5 or 6 questions in the announcement section, and I want you to add those on there because I need your feedback. So I need you to do that. I need your feedback. Because this is the first time I've done an online course, and I might end up doing it in the future. So I really need your feedback. So I'm willing to give you guys 5 points. And if I can get greater than 75% on those course evaluations, which are open now, you'll get an email from EKU, or you can go under your course evaluation in Blackboard and choose me and give me feedback. I won't get those until long after you have your grade assigned, but I do value that, and I will round your all's final exam grade up, your final grade up by 1%. So I just tack on a 1%. This really helps people with borderline, okay, grades. I don't see myself doing a lot of rounding, so this will be really important that you do that. All right, let's go over your, I'm going to go over the open response first for quiz 5, and then we're going to go over the multiple choice. So your open response, a lot of people got this one right. So you do excess methylamine, and then you react it with silver oxide, water, and heat. And I also asked for this mechanism. And so here you have an alpha carbon, and you have your beta here, and you have your beta here. And this is, what happens is this over alkylates. And so this will over alkylate, and you'll eventually get this quaternary ammonium salt. Now this is a Hoffman leaving group. So a Hoffman leaving group means a bulky leaving group. And so that means the beta hydrogen, so between this you can generate OH minus, that base that will abstract the beta hydrogen from to give you the least substituted alkene. So that's a Hoffman alkene. Do you remember the other alkene? Zatsevs. And I really like this reaction now because it should lead you into going back and reviewing Zatsevs and Hoffman bases, and that would be the E2 mechanism to make alkenes, and you really need to start reviewing. So that should send you back into review mode, because your final exam next week will be all of those from Organic 1. All right, so now the next one, we fill in the starting material here, and you have an amine. This is methylamine. Have you all noticed that your open response questions were 1 and 2 here? Okay, they're just the mechanism. Now, so here's methylamine, and you need, this is reductive amination. This is a secondary amine. You always want to classify your amine. This nitrogen is bonded to 2 carbons. That makes it a secondary amine, so we need to use reductive amination. Well, what's reductive amination? You actually need a little bit of acid to get this to go because you have a ketone. Well, in this case, it's an aldehyde. So here's your carbon here, and so this is your aldehyde. So this carbon here is that carbon there. This carbon here is this carbon here. Now, reductive amination, what's the mechanism on that? You make an amine. So you did this with your ketone and aldehyde chapters. That's why you need a little bit of H3O plus, because this is a weak electrophile. Remember the carbonyls are weak electrophiles, so we've got to make them stronger electrophiles. So we first protonate the carbonyl oxygen, and then we have the weak nucleophile, which is your methylamine, and this is going to make a tetrahedral intermediate. And as you can see, we still need to take this water here. This becomes water, and we'll need to deprotonate this to get a neutral intermediate, which makes your catalytic acid. And now we have this intermediate. And so this is review, folks. What's going to happen now? We've got a hemiaminal. Does this look familiar? Hemiaminal. We're going to protonate the water. We want the water to be a leaving group. That's why we need a little bit of acid. And that is leaving group, and we get and then that water will regenerate to H3O plus, catalytic acid. And what is this functional group? This is an amine. And then when you reduce that, sodium cyanoborohydride, or you can use, I mean, that's what everybody pretty much uses. You could use also lithium aluminum hydride, that would work. But sodium cyanoborohydride, it's a 3 by the way, is basically a hydride here. This is carbonyl, and you don't have to know the mechanism because this is reduction, but you're going to add basically hydrogen to this carbon, and you're going to add a hydrogen to the amine, and this makes your secondary amine. And this is reductive amination, and that's the mechanism. Okay, the other question here. A lot of people miss this for different reasons. Okay, so this is an SN2 reaction, right? So are we kind of reviewing a little bit, which is good. So this does an SN2 reaction. And when you get like 1, 2, 3, it's good to break these down into each individual parts. SN2 does inversion stereochemistry. Now let's actually go ahead and draw out that Lewis structure. Okay, now we have a nitrile. Do you see how we added an extra carbon there? So now when we reduce nitriles with lithium aluminum hydride, and we treat it with H3O plus, which is the workup that you need to do with the lithium aluminum hydride, this is going to reduce. And I don't even like doing it this way when I'm just go ahead and draw a correct Lewis structure here. Do you see how we added this carbon here? So this this has, count your carbons, 5 carbons. This has 6 carbons. So potassium cyanide adds a carbon and makes the primary amine. So if you ever need to go from 5 carbons to 6 carbons, then this would be a good reagent to use. I try to choose these questions on the quiz so you see these little differences, these nuances. Okay, here we have an alkyl halide, a primary alkyl halide, and we have a primary amine. Okay, so anytime you have a primary amine, you should think Gabriel synthesis. Okay, it's a great synthesis, and that means you use potassium thalamide salt. You can actually buy this salt, potassium salt. If you actually put a hydrogen there, then you better add a base because it's not right, because you got to get this imide nucleophile, and then you're going to treat it with hydrazine and heat. So what happens here? It's just does an SN2. So the first step, and so 1, 2, 3, 1, 2, 3. This is the nitrogen that's going to be added. So this is going to be your nitrogen. This is going to be your 1, 2, 3. We don't care about the reagents because we'll wash those away with a separatory funnel, but we do care hydrazine here. We do care about, by the way, hydrazine you gotta be careful with. We do care about the amine. So what we end up getting is a displacement. So this is thiamidohydrazide, and then this gets released to make the amine. Okay, so that's a good way to make a primary amine. The next reaction was a synthesis, so you're going to have to start doing synthesis, where you're given a final product and you're asked to synthesize it. This is very much like your first problem. It asks you to use methylamine, so this is problem number 2, and it's a lot like the first page with number 2. So here's your methylamine. So these pieces belong to this. And this is a secondary amine. So a secondary amine, you need to think reductive amination. And people that got a perfect score, I'm assuming you took your time and really looked at the POGIL videos and worked those POGIL problems. So you have to have a little bit of acid on this because we showed that amine formation. So the first thing you're going to do is you'll make the amine. And then the second thing you're going to do is you're going to reduce this with sodium cyanoborohydride, which will make, I'll just write the word product. You could also use HCl, or I mean lithium aluminum hydride. And if you do that, you also want to add acid because aluminum forms a strong complex with the nitrogen. And if you don't do a workup with the acid, you're going to lose it in your water phase. And then you'll be like, where did my product go? Okay, let's go to 3. Draw the reaction mechanism. All right, so this was in your POGIL. I really did want you to go through it all. When I ask for reaction mechanism, I don't expect any shortcuts. Okay, so this is your SN2 reaction, and I wanted to see that you could show your electron flow arrows. And so, and I wanted to see that you could get your formal charges. So this is a plus, and then a lot of people did H minus to deprotonate. Now you have a nucleophile again. And if I saw that you did this several times, and I felt confident that you understood what was happening, I gave you credit for it. So, because this is the same thing over and over, right? So, we do that again. And then it does it again. You see I have 2 electron flow arrows. Okay, some people don't put both, or you lose a half of a point. I would love to give you all your points, okay? Now this is a Hoffman leaving group. So that means we have an alpha carbon here. And so when we're doing, and this is an E2 reaction, and these are our beta hydrogens, then you could just do silver oxide and H2O2 and heat. This makes OH minus. It's going to take this particular hydrogen, and you see how I have 3 electron flow arrows there to show my elimination. So you lost a point if you chose the wrong beta hydrogen. 1, 2, 3, 1, 2, 3. So this is a Hoffman product. And then we had one more question, and this was just an acid-base reaction. So the acid-base reaction, and if you go on to your next chapter, this does not make an amide. If you wanted to make an amide, like some people wanted to make an amide, you'd have to convert this to the carboxylic acid into an acid chloride. And you would do that with what reagent? Thionyl chloride, SOCl2. Okay, so this is just acid base. I just wanted to say, okay, there's my acid. This is my base. I wanted to say that acids use some pK values. This is between 4 and 5. And then you show your electron flow arrows from the nucleophile. In this case, the electrophile is the acid proton here. And then I wanted to see that you could draw your products. And this is a conjugate base, and then this is your conjugate acid. So this gets a plus, this is your conjugate acid, and then you have to assign a pKa to your conjugate acid, and this is 11. Okay, so the equilibrium arrows for acid-base reactions go towards the higher pKa. So equilibrium arrows point to the higher pKa between the acid versus your conjugate acid, and the higher pKa is your weaker acid. Now this is another review because you have acid-base reactions. Your final exam is going to have you do these kind of things, okay? So this is how you do all acid-base reactions, and that was one of the reasons why I brought that in. All right, so going to your multiple choice questions on your quizzes. Okay, so we are also starting the chapter on carboxylic acids, and you are to rank these carboxylic acids in terms of acidity. Probably could have looked up all the pKa values. I write these as if you would have had to memorize. So the way you would figure this out is this is electron withdrawing group. Fluorine has the highest electronegativity. So if you were to make your conjugate acid here, conjugate base, then how stable is this conjugate base? Well, this fluorine will pull, you see 3 bonds there? Will pull that electron density towards itself, which makes this more acidic. So this is going to be your most. So that's 1. And then the next one would be chlorine, because chlorine is an electron withdrawing group, and it's 3 bonds away. So this would be second, most acidic. And then the fluorine, 1, 2, 3 bonds away. So this is your alpha carbon, this is your beta. These are your alpha. So this would be third, and then this would be fourth, because it has no electron withdrawing group. Another ranking for amines and their basicity. So this is the rank for acidity, and let's rank basicity. So ranking your basicity, and you know you had some problems like that. You also have extra problems assigned to you in the book. So this would be plenty of resources. You just have to really take the time and also focus. Okay, so what we have here is an amide, okay, not basic. They're not acidic and they're not basic. Here we have an aliphatic amine. Okay, these are going to be your most basic. And then this is going to be your second. So this is the first, and this is your second. Because this is ammonia, it has no electron donating groups. So this is opposite of what we just saw with the acids. These alkyl groups are electron donating. So they're pushing electron density towards the nitrogen and makes this lone pair more nucleophilic, okay? It makes it a stronger nucleophile, which makes it a stronger base. And then this is an aromatic amine, okay? So these are about a pKb of around 3 or less. These are a pKb around 8. So the lower the pKb value, the stronger the base, just like the acid world. So this would be third, and this would be fourth, last. All right. Now we have 3 reactions. This one, we've seen this one before. And it might be the exact one, right? So hopefully you understand the Hoffman elimination and heat. I think I made a mistake on that other one. It should be just water. Okay, so hopefully you chose this product here. Okay, that is the elimination, Hoffman elimination. All right, the next one is we have a alcohol. Alcohols are horrible leaving groups. We've got to predict the reagents. And what have we made here? We've made a primary amine. So I would like, oh, we got a primary amine. So I'm thinking Gabriel synthesis. And we're going to count carbons. 1, 2, 1, 2. So 5, 6, 7 carbons, 7 carbons. So we don't want like one of the options are KCN. Well, you only want that if you're increasing your number of carbons. So we can eliminate that one. One of them is the Hoffman elimination, but that makes alkenes, so we can eliminate that one. We have two, one of them that uses tolusyl chloride and pyridine. Why would that happen? Why would we want to do that? We want to make it a good leaving group. So that makes the tolusyl. Okay, that's a great leaving group. Another one does PBr3. PBr3. Well, that converts the alcohol into an alkyl bromide. That's a good leaving group. So both of those are good because OH is not going to leave. But this one does the Gabriel synthesis. So we see the potassium thiamide and then hydrazine. So that would be great because this will do an SN2 and you get this intermediate. Okay, and then the hydrazine will release the product. This one here, sodium cyanide, does the same thing. Cyanide will do the same thing as potassium cyanide. And now what you have is 1, 2, so you have 7 carbons. Here you have 8 carbons. And so then you do reduction, lithium aluminum hydride, and you have your primary amine, which you have 8 carbons. So these are your better reagents for making amines. Last one, predicting starting material. All right, so we have this product, and we have an amine, and I should have H3O plus on here. Make sure you do. And sodium cyanoborohydride. So this is a secondary amine. And you also had this on your open response. This is reductive amination, folks. So you need to know reductive amination needs the amine, which is coming from here, a little bit of acid catalyst, and then this is a ketone. Okay, so that's the thing. This is a ketone. And you see that you have them written out as Lewis structures, condensed structures. So sometimes you have to take the answers and write them out. The other one was CH3, CH2, C aldehyde, and then you had this one. You might want to convert them to line structures. So this is the options, A, B, C, and D, or whatever, but you want the ketone. So you work it like this, you ask your questions, and then you look at the answers and find the one that matches. And that's going to be important. So if I were you, when I was working these multiple choice questions, I would get out a blank sheet of paper and I'd work them like they're open response, and then I would go in and look at the answers. At this point, just fill out your evaluations. I need that. I will be generous to you because you took the time to give me feedback, and I need your feedback. And if you have questions, send me questions. Good luck tomorrow.